Today, we're going to take a look at one of the most beautiful and surprising patterns in mathematics. On the blackboard behind me, something curious is unfolding. On the left-hand side here, we are adding up the first few odd numbers. And on the right-hand side here, we are writing down the result of that sum. Now, at a first glance, this may seem like a random jungle of numbers. But if we take a closer look, something curious is happening. We can see that the sum of the first two odd numbers is 4, which is 2 squared, right? 2 times 2. The sum of the first three odd numbers is 9, which is 3 squared. The sum of the first 4 odd numbers is 16, which is 4 squared. And the sum of the first 5 odd numbers is 25. And there's no space here, but that's 5 squared. So somehow, adding up odd numbers, something that feels linear and step by step, is producing perfect squares, something that feels geometric, structured, almost architectural. And that seems quite strange, because summing up odd numbers and building perfect squares have nothing to do with each other. So why should this pattern continue to emerge? Why should these two ideas be secretly connected? This why is what we are going to investigate in this problem. And we are going to do this not by building a calculation, but by devising a proof. A narrative of some kind that explains why this pattern should hold all the time. And we are going to do this in the most exciting way possible, that is visually. So let's begin by thinking carefully about what a square number is. For example, let's take the square number 9. That's just 3 times 3. Now to visualize this, let's draw out the number 3. So this is a physical representation of the number 3 and repeat it 3 times. And we can see over here this square shape begin to emerge. So the number 9, which is a square number, can literally be visualized as a square. And this is the case for any square number. So the main point is, square numbers are not just abstract symbols. They are geometric objects. Now let's be very clear about what we are trying to prove here. We are trying to say that the sum of the first n odd numbers is just n squared. And that would apply for any n that's a natural number. In simple terms, what we are saying is that any square design, as we saw visually, can be broken down into smaller pieces whose sizes are just the odd numbers. And what we're going to do now is we're going to test this idea visually. Consider the square number 25. To visualize this, we construct a 5 by 5 square as such. And we begin to check if indeed there is a sequence of odd numbers that make up this square. A sequence of odd numbers that is secretly hiding inside this square. This is a good moment to pause and check if you yourself can find such a sequence, but if not, you can just follow along. So at first, nothing obvious jumps out. Maybe, we have a 1 here, we have a 3 there, we could have a 4 here. That doesn't seem to work out. Maybe we could have a 1 here, and then I suppose a 3 there. This would be 5. Where's the next one? But suddenly, check this out. We have a 1 here, we have 3 there, we have a 5 here, we have a 7 there, and we have a 9 here. Wow, we can see that a square, if we think of it as a sequence of these L shapes, we can see the 1 here, we can see the 3 here, we have the 5 here, we have the 7 here, and we have the 9 here. Suddenly we see that our pattern is just hiding within the square. Now, this visualization seems quite exciting. It's quite convincing, and it kind of gave me a feeling of delight and a feeling of revelation. I hope you experienced that too. But we must not get carried away. Just because we found this pattern taking place for this one particular square number that was 25, could we be so sure that this pattern would carry on in the next square number, in the one after that, perhaps 1 million times after? Who knows? Our key observation was this, that a square is made up of one L shape nested within another L shape, which is nested within another bigger L shape, and so on. So in order to confirm that our pattern will hold in eternity, what we're going to do now is take a closer look, examine very carefully this L shape. So over here, I've drawn out a generic L shape. This L shape is meant to capture every single L shape in existence. And these dots here just signify that the L shape can be as large or as small as we want it to be. And what I want us to notice here, that structurally, this L shape is made up of one joint over here and two arms. So no matter what L shape we have, structurally we can break it down into two arms and one joint. Now notice something important. The L shape, its two arms without the joint over here always have the same length. This means that when we add up the two arms of the L shape, barring the joint, it will result in an even number. This is simply because if you take any two numbers of the same size and you add them up, it's an even number. And then if we add up this joint over here, the final result is an odd number. This proves that no matter how large an L shape we have, no matter how large or how small it will always be odd in size. Now take a look at what happens as we go from one L shape to the next L shape. Over here in the interior, we have the L shape that we had initially drawn, and this is the next one. Now for both these L shapes, of course, there will be just one joint. But what happens to the arms as we go from one L shape to the next one? We can see that each arm grows by exactly one. So the total L shape grows by 2. This tells us that each successive L shape increases by 2, and that is the very definition of consecutive odd numbers. And this is our crucial insight here, that will allow us to claim that a pattern continues to exist in eternity. So to sum up what we have discovered here, we see that a square grows by adding one L shape at a time, right? Each new L shape, each successive L shape contributes to the next odd number. And when we add up all of the dots together, we get a perfect square. This is why the pattern doesn't stop. This is why the pattern works for every square. And this is why the sum of the first n odd numbers is n squared. We have proved that adding consecutive odd numbers leads to forming perfect squares. And we did this by drawing simple and intuitive pictures, not relying on calculations or formulas. Now to demonstrate how insane it is what we accomplished here, let's imagine that these perfect square numbers on the right hand side personify the perfect woman. Now this is the woman that you've always dreamt of. She's beautiful, she's symmetrical, she's complete. And you'd imagine that to attain this sort of perfection, you'd have to be perfect yourself. But no, mathematics says no. In order to attain this kind of perfection, it is done by stacking up oddities. And in fact, the more perfect the woman gets, the more you have to lean on your oddities. The more you have to stack them up. And perhaps there's a message here that to attain perfection, you really have to be unapologetically odd. And no, this is not dating advice. This is mathematics.